So today we're going to be doing the final column, which is questions 108 through 110. So without further ado, let's jump into the first one, which is 108. Okay, so suppose a student's test scores have a normal distribution with a mean of 78 and a standard deviation of 5. What is the z-score of a test earning a 72? Okay, so let's go ahead and sketch an idea of what's going on. We have a normal curve. We have a mean of 78. We have a standard deviation of 5, which means from here to here, which is going to be 83 and 73. So between these two scores, 68% of the tests lie. We want to know what is the z-score of a test earning a 72. So right here. So 72. So we're outside of the first deviation, so we know it's going to be greater than 1. It's going to be 1 point something because it's not within the second deviation. So let's go ahead and set up what we know is the formula for the z-score. Now also, if you forget this formula, remember that this is listed on our given formulas. The z-score is x minus mu over sigma. Where it says mu is the mean and sigma is the standard deviation. So we have that set up. So we know it's x minus mu over sigma. We know the mean is going to be, can't see that, 78. So the mean, or actually no, our x is not the mean. Our x is our data point, which is going to be 72, minus mu, which is going to be our mean of 78, all over the standard deviation, which we said was 5. Okay, so negative 72 minus 78 over 5 is negative 6/5, which is going to be negative 1.2. Our z-score for that score, given that deviation, is going to be negative 1.2. Perfect. That was number 108. Let's take a look at 109. So 109, we said if all the tests in the class are normally distributed, so we have another normalized curve. We have a mean score of 78, so here's my 78, and a standard deviation of 5, so I have from here to here, so from 73 to 83, we have 68% of all scores. What percentage of test scores would be at an 88 or above? So I'm looking at right here at an 88. Now, conveniently, this has been chosen to represent what we're seeing as the next deviation. We noticed if it's plus 5, this is exactly 2 deviations over. And that is because from 88 to, 68, we have our second level of the empirical rule. 68% of all tests are within 1 deviation. 95% of all tests are within 2 deviations. But we're not necessarily concerned with what's between 2 deviations. We want to know what is 88 or above. So I want to know what's on this right end of the curve. Okay? Well, if 95% of all scores are between here, that means 5% exists on the outside edges. And I'm only looking at one outside edge. So if 5% exists on both ends, so I have 5% in the tails combined. That means that 2.5% of all students scored an 88 or above. Awesome. That's 109. Let's take a look at 110. Okay, so 110 says that if all test scores in the class are normally distributed, so we have again a normal distribution with a mean of 72, so I have 72 as my mean, and a standard deviation of 3. So that means if I'm going from 3 down is 69, 3 up is 75. what percentage of test scores would be 75 or below? Okay. So before we even begin, we know this is one deviation away, which means 68% of all students score here. We are concerned with exactly at that one deviation mark, and I want to know what percentage of students score 75 or below. So I'm looking at all of this all the way down to the very, very bottom. Okay. Well, I know if 68% score between these two brackets, then that means that 32% score in each of these brackets. So what I have is I have area 1, which is 68, and then half of 32, which is going to be 16%. So I'm looking at 68% score here and 16% score over here. The remaining bit would be, let's just do this in black, would be another 16. So I have 16 and 16 and 68 add up to 100%. So I'm looking at these two values over here. So we have 16 plus 6. So 16 plus 68 is going to be 78, 84. So I have 84% of all students scored at or below a 75. And there we go.